Today our topic is equations of motion.
Why do we study equations of motion? Because they provide us the relation between distance, initial velocity, which is also known as initial speed here, final velocity, acceleration and time. So let's start with our first equation of motion. Uh, First equation of motion is derived by using this graph, and we shall use same graph for second and third equations. In this graph you can see that there is a triangle ACB. For first equation we shall solve this triangle. You can see that there is slope in the line A and B, that is, it is inclined. Anything which is inclined, it possesses slope. So there is slope in line AB. To calculate slope, we use a trigonometric ratio which is tan theta. So slope of line AB is equal to tan theta. Formula of tan theta is perpendicular divided by base. In this triangle, perpendicular is BC and base is AC. So slope of the line will be equal to BC divided by AC. In any such figure which is relating velocity and time, then the inclined line gives acceleration. So line AB gives acceleration, which will be equal to BD minus CD divided by AC. You can see in the graph, there is written at the top of the graph that how is BC equal to BD minus CD. From figure we can see that BD is equal to VF, which is written at the extreme right, and similarly CD is equal to VI. So A is equal to VF minus VI, and at the bottom it is given that AC is equal to T. So AC is equal to T. Putting these values, A is equal to VF minus VI divided by T. Now we shall arrange this equation. VF will be equal to VF minus VI is equal to AT, or VF is equal to VI plus AT. This is first equation of motion. Second equation of motion is used to calculate distance. So in any velocity time graph, area under velocity time graph is distance. So area is OABD. O. This is whole area, which consists of a rectangle OACD and a triangle ACB. So total distance covered will be equal to area of rectangle plus area of triangle. Using the formulas of rectangle and triangle, total distance covered is equal to area of rectangle plus area of triangle. Distance is denoted by S, which is equal to area of rectangle is equal to height multiplied by its length, where height is CD and length is OD from figure. Similarly, area of triangle is 1 by 2 base multiplied by height, which is 1 by 2 base is AC and its height is BC. So putting these values and using the notation at the top of the graph, it is equal to S is equal to VIT plus 1 by 2 AT square. It is second equation of motion. We shall use same graph for third equation of motion, velocity time, and we also calculate distance in third equation of motion, but in this distance we do not divide this figure. Initially we divided it from this line AC. We took a rectangle below it and a triangle above it. If we take the whole figure OABDO, then it is a trapezium. So total distance covered will be equal to area of this trapezium. Formula for trapezium is total distance covered is equal to S. Formula for this trapezium is sum of parallel sides divided by 2 multiplied by base. You need to learn this formula. So S will be equal to, parallel sides are OA and BD. Parallel sides are those sides which, if extended, do not intersect each other, and its base is OD. So one step which you need to remember is that multiplying by BC over OD on both sides. Why do we multiply both sides by BC over OD? This is because we want to complete a formula which you have studied in mathematics, A plus B into A minus B, which will come next. So S into BC over OD is equal to, putting values on for CD and OA, then VF plus VI divided by 2 multiplied by OD. what we have written at the top, multiplying by BC over OD, that is why we have written in this step BC over OD. So on the left hand side, putting the value of BC and OD, S into AT divided by T is equal to VF plus VI divided by 2 into BC. BC is equal to VF minus VI. How? You can use the first equation of motion, that how do we put value of BC here? We have substituted similarly. So 2AS is equal to VF plus VI into VF minus VI. Multiplying these two or putting them in the formula A plus B into A minus B, then 2AS is equal to VF square minus VI square, which is third equation of motion. Point need to remember about these equations of motion is that in equations of motion we did not mention whether the quantity is vector or scalar. We did not put any arrow on velocity, or we did not put any arrow or line over acceleration. This is because we only take magnitudes in these equations of motion. We do not take direction, to simplify. That is why at the start I mentioned in the learning objectives that equations of motion relate initial velocity or initial speed. How can initial velocity be initial speed? If we remove its direction. If we just take magnitude of initial velocity or final velocity, then it becomes initial speed or final speed respectively.